But what I really want to talk about is, of course, the larger issues here, and this is probably no surprise for you, but in across Europe, and that goes for Denmark as well, we have 40% of our energy, total energy consumption is actually used in buildings. And that leads to 36% of our total CO2 emissions are actually emitted from our homes and our buildings around Europe. So there's a lot of good reason why the European Commission with the renovation wave has really focused on let's get these building climate optimized as fast as possible, because this is really where we see the big challenge across Europe. And this is a key really to in order to meet the Paris climate agreement. The challenge is, of course, that we have a very old building stock across Europe, and we see that it's only about 10% of the buildings in Europe are energy optimized in the way they should be. And the problem is also that we have a very low renovation rate. So it's like 1 to 2% in the building stock is renovated each year, and the percentage of new build is also quite low. It's only like, I think it's about 1.5% a year. So basically, the buildings we have today, about 90% of 80% of them will be there still existing in 2050. So we need to do about this something about this. And when we talk about this kind of climate mitigation or climate proofing, as you call it, there tends to be a lot of focus on the how to prevent the water from coming in due to more humid weather, more rain, and more floods and all of that. And this is something in Denmark that we're very preoccupied with also. But also, I think we need to also recognize that in order for a home to be and a house and a building, an office to be really future-proof and to be resilient in the future, we need to address some of the urgent matters that we see in today's buildings. And that has to do with that we today spend about 80% of our time indoor, and that's including transport. But basically, so we live and work and we play indoor most of the time. And that means that the indoor climate really has a huge impact in our health altogether. And as a Harvard professor, Joseph Allen, said in a conference I attended a year ago, the people who design and maintain our buildings have a better or bigger impact on our health than our doctor. So that's quite striking, but very true. So when we are looking at the challenges in the existing building stock, we need to recognize that we need a holistic approach. There's a lot of different elements that are important here. One is, of course, a challenge of the cities are growing all over Europe, and the suburbs are growing even more. So there's definitely a lack of spaces, and what we can see is that there's still a lot of potential of including extra space in the attics, and this is why you can, for instance, in Copenhagen, you have the potential of 22,000 new residents alone if you would include unused attics around in Copenhagen. And this is a similar picture you have all over Europe. So there's a challenge there, and we have the buildings that are way too dark. We do not recognize the effects of daylight as much as we should do. You can't really substitute daylight to electric lighting. You only have about 70 parameters in electric lighting today, whereas daylight has over 300. So you cannot really get that same health effect of electric lighting as you have with daylight. So that's another important point. Then we have, as I mentioned, a huge amount of energy waste in buildings because they're not energy optimized. And this one about overheating, well, that maybe not so much of interest in the Baltic region or in Denmark, where we usually don't get so hot summers. However, in 2018, we did get a lot of overheating problem even in Northern Europe, and this is probably something that we will look into the future. But Southern Europe is definitely hurting a lot here, and this leads to a lot of deaths every year, premature deaths. And then we have all the health issues of mold and smell. So this damp and mold buildings can really cause a big health issue. Another thing is, which is not mentioned here, is excess noise. And this is something that we build our studies on. The 4 risk factors that will be that the buildings are too cold, that they are mold and damp and mold, and that they are too dark, and that you have excess noise. I'll come back to that. So really, what we need to transform European housing into healthy and sustainable living spaces, and to look at some of those questions and to really get an answer to that, VELUX perform every year a Healthy Homes Barometer, which kind of takes the pulse of the European home and buildings to examine how they can be improved in the benefit of individual society, but also planet eventually. And what we do is that we cooperate with an esteemed institute that has been Egerfes and Navigant, as it's called today. But the last 2 years, we have worked with RAND Europe, a nonprofit institute that is very focused on health. So we've been doing this yearly publication since 2015, and we'll continue doing them because it definitely qualifies the debate, and it gives us a lot of knowledge about how our own products can be improved to really handle some of those challenges. But let's look at the challenges first, and I'll go quite quickly through this because I want to go to the concrete examples of how you can have solutions to dealing with them. But we learned in our barometer in 2017 that 1 out of 6 Europeans live in unhealthy buildings, and this is a surprisingly high number because it's equivalent to 80 million Europeans. However, in the 19 barometer, we looked at the children, and what we saw was that children was affected much more severely than the elderly, and we say, okay, we need to ask ourselves the fundamental questions: are our homes making our children sick? And that's what the study did. And when we look at the risk factor, the 4 risk factors I mentioned, we see that 1 out of 3 children live in unhealthy homes. And this is a study based on the European SILT database. This is part of Eurostat, where you question, you have something like 260,000 respondents all over Europe, and you do this quite thoroughly questionnaires. So they've been doing that since the 60s, I think. And this is a surprisingly high number. So we're talking about over 26 million children. That's more than the entire population of Scandinavia actually living in homes that could harm their health potentially. And when you look at it, as I mentioned, it's dampness, it's darkness, and it's excess noise, and it's cold temperatures that they're struggling with. And if you live in a home with just one of those risk factors, you have 1.7 times more likely to report poor health. And if you live with all 4 risk factors, you're looking at 4.2 times more chance to report poor health. And the consequences of living with one of these risk factors are the same regardless of socioeconomic studies. So damp and mold and lack of light don't really distinguish between a rich and poor, but of course you're more likely to live in an unhealthy home that has not been maintained if you come from a social background, which is the last 20% of the income scale. So they are much more likely to live in those homes, and then you have like it's 25% that you are more likely to live in an unhealthy home if you belong to the lower 20% of the income scale. And so the diseases we're talking about is ischemia, it's pneumonia, asthma, allergies. And interesting thing about these is that they are all diseases that are increasing quite a lot, especially allergy and asthma. And for asthma, we think about 40% of the asthma cases in Europe has to do with unhealthy buildings. That's not our study, but that's what's been said here. And the horrible thing is that those diseases many times can follow children into the rest of their lives. So the social economics and welfare of the children it's quite significant. So when we look across Europe, the scale of the problem varies quite a lot. You see that that um, well, countries like Finland and actually Estonia are doing quite well in this. Denmark is pretty much in the European average, like 1 out of 3 children. And then you have Lithuania and Latvia is also struggling. But the interesting thing about that, even when you look at countries like Finland, Croatia, and Estonia, you see a difference, of course, but even in the best cases, we are still talking about 20% of the children being at risk. So there's no country that is home safe when it comes to this. And please do interrupt me if you have any question. I forgot to say that. When we look at when the children not in home, they're often in school, and each year diseases from damp and mold is responsible for European children missing 1.7 million school days. This means that each children in Europe misses 1.5 school days each year, and maybe 1.5 school days doesn't seem like a significant number, but however, this is on top of the absence caused by other illnesses and other reasons. So if you only have like damp and mold is the only one of the 4 risk factors, the total number of missed school day is most likely much higher. And this has a significant impact. We also know that the environment at the school is quite important. This I think it's Fraunhofer has made this enormous study where they looked at just a simple thing as air quality in the classroom, and it shows that you can actually, by improving air quality just to the recommended ventilation rates, you can really boost performance by 15%, and this is having an positive effect on both working speed, attention level, and concentration. And fewer studies, because we haven't had that many studies on this, but there's been some studies on daylight also, and you show similar results, saying if you have a student making a test next to a window instead of in the middle of a classroom, they tend to perform up to 20% better doing those same tests. And this, of course, has an enormous impact on the individual child and family, but also when you look at the consequences for the economy across Europe, and we actually have numbers for this also for each European country. So just by increasing ventilation in schools, in 2060 you can actually have economic benefits of 250 billion euros. And reducing exposure to mold and damp in homes, we're talking about over 50 billion euros in 2060. So you have something like over 300 billion euros to be gained here. And this is important because we're talking about climate challenges that are being dealt with at the same time. So if you have renovation and health going hand in hand when you do renovations, well, you can cut a lot of that climate bill in 2050 if you ensure to really grab those health benefits. And these are some of the benefits we are talking about. So the positive note is, of course, that we can do a lot to make our homes more healthy, and we don't have to sit around for huge, large technological discoveries, since the solutions are already here today. So let me be more concrete here. We try to work with this also in practical terms. Our funder used to say that one test is worth more than 1,000 assumptions. So really, once you have some solution, you want to test them out. And what we've done is that we built this model home, which are a new build, and used what we call active house principles, ensuring basically that energy efficiency and health goes hand in hand. However, the big challenge, as I mentioned before, is in the existing buildings, and this is why we have made this concept test out on the active house principles. This is actually a certification that a big partnership with a lot of other organizations and institutes. So we took a housing, a social housing in Belgium, where they have very strict budget. And we said, well, how can we make this kind of old and run down apartment with very bad condition, and how we can apply this Renovation concept, and so the house will flow with daylight and fresh air, and become very energy efficient. And we saw that our calculation that the energy bill can be reduced to up to 50%. So this is a before and after the renovation of that. So we kept the whole project within the very tight framework of the that housing association, and work with that with some other partners. And so these are the 7 elements that we've been working with. We have been wanting to grow within. That means including the attic that was unused before, and also give it a daylight treatment, adding more windows and ensuring more daylight, and also a respiratory challenge. So we have a flow, and securing the house envelope. So not only just insulating, but also have shutters and that can go down at night, and keep that envelope more tight, and actually also keep the sun out if there's a chance of overheating. So, and of course the envelope, the technical installations were upgraded, and there were added some more space, as you can see in the last one here. So here in the left corner, you see how it looked before, and what it was turned into. So of course you get better living spaces out of this, but besides from the health and the energy gains that were here, and also you see the attic were now turned into a quite nice living space. In this particular house, of course, you didn't have so much room in height, but it's definitely good for children room. And this is kind of how the ventilation shaft were created now, instead of just a small door on the floor. So we had the construction here was 6 months, and then we had open for visitors. We started just with one house, and then we had a family that moved in, and we monitored that family for 2 years just to see the effects here. And we had external monitors partners who did that actual work, and this is kind of the overview of the partners involved. So we did talk with the people living there. Of course, we're quite interested in that. And the family, they used to live in an old apartment with very cold temperatures and visible problems with mold. And what they gained here was a much more comfortable indoor living temperatures. They actually turned up the heat a lot more than they were supposed to. So you have the rebound effect, of course, but still the energy consumption was reduced. And they also talked about other aspects, like they had more friends coming over to visit them. So the whole social aspect of living there gave them more value also in that aspect. They could really feel the of being in control rather than being controlled by your circumstances. And so they really felt a huge change in their life because of those living conditions being changed. And just one mention is that we did one of those model home we built, a new built house. We had a family moved in there, and one of the children was asthmatic. And during the time they lived in that building for 2 years, where we monitored them, the parents told us that they actually quit the medication for that child with asthma, because she didn't have any attacks of asthma during that time. That's quite thought-provoking. Yeah, I'm gonna go through that, but more positive experiences they had with living in the new with the new home. So if we summarize the Renovation here, the home satisfaction is very high. The health and the sleep quality have been improved. The improve family life as well as social contact. And the extended strategy of the house is operating slightly different by the family. They had turned up the temperatures the first year, but this was something they started regulating also because they saw, okay, we can actually do a lot in terms of keeping our costs down if we don't use as high temperatures. And that the flexible and robust technical system operating indoor environment is really essential to accommodate occupants' preferences, and that the future system of detecting a significant divergence from the planned parameter could return to the default setting, and also provide feedback from occupants to allow them to really make informed decisions, saying, well, if you turn up the heat a lot more than actually needed, you have this increased energy bill, for instance. So before ending this, I just want to turn your attention also to the potential in the public buildings. So we had done some school renovations where we had a partnership with the several municipalities in Denmark. This is one of the first one that we did indoor school in Northern Sjælland. And this is a typical Danish school from the 70s that is located in Fredensborg. So it consists of a series of low-raised buildings that offer about 7,000 square meters indoor space. And the school housed about 350 students and over 50 teachers who regularly enjoyed a beautiful countryside and tranquil surroundings of a park. But they also had the issues with lack of daylight and really poor indoor air quality. So until recently, the schools were lacking those factors, and and it's proven that as I mentioned before, that the well-being and concentration is consequently harmed by this, and that's also the ability to work. So we did a renovation project, and why I like this project is that it was only like 1/4 of the usual cost, because when you do have other schools construction with many multiple layers, you would need a quite expensive ventilation system. However, here we did that with an intelligent roof light window system called VELUX Active, where you have sensor monitoring all the different climate aspects, such as humidity, CO2 levels in the room, and cold and warm, and communicates with the weather report, so it doesn't open when you have wind and when you have rain coming. So it really regulates the temperature indoor, and that way intelligently makes sure that there's a comfortable and good indoor climate, like a mild, warm summer day, basically. And this became a kind of a project that we did in many different schools after this one, and it really turned out to work quite well. And what we can see is that today the students and the teachers, they report a dramatic difference in the classroom or atmosphere, and not only enjoy the energizing daylight and fresh air, but also find themselves more connected to the surrounding nature. And the inter-school project also served as a source of inspiration and best practice for lots of our school renovations that we've seen. And one of the questions I remember one of the teachers said, well, is it really intelligent to have windows doing all the work for you? Don't we have an ability to teach children how to operate windows and ensure that we actually have fresh air? And that was kind of interesting. So we made a project together with a company called Leapcraft, who specializes in sensors, and they created this Airbird, which is basically an instrument that you put in a classroom, or you can put in your office or home, and that will give you an alarm if you have an issue with the air quality or other aspects. So, and this reports to an app saying what is the problem now. So it gives you kind of alarm. It's kind of inspired by the the canaries that you usually have in the coal mines. So if there was a gas leak, they would die, and then you have to get out of the coal mine as soon as possible. Here is the airboat doesn't die; it just gives out an alarm to the people living there or spending time indoor. Yeah. So the conclusion is quite simple. When we are talking about climate proofing the building stock and and securing the future, we need to have a holistic approach to renovating the existing buildings, and we need to ensure that the health and energy efficiency go hand in hand, basically. I think that the whole COVID-19 has definitely also changed a lot the people's conception or idea about what is a good indoor climate, and we can also see that ventilation has a huge impact on the spread of virus indoor. At first, in the pandemic, we tend to looked a lot about droplets that like surface on tables that we need to clean to make sure the virus doesn't spread. However, it turned out that the virus was much more airborne than assumed at first, and so when we assure a building to have the right amount of ventilation, both mechanic and natural ventilation, because you can get a stacked effect with the natural ventilation, then we can really secure the building much more from spreading viruses across. Yeah, that's it from my side.